Hello and welcome to our tutorial video about the MIPI C-PHY CTS receiver testing software. The M8085A MIPI C-PHY receiver test software supports automatic control of M8190 and M8195 AWG system. It allows configuration for single and multi-lane testing of the test device, also known as DOT, and was developed to perform conformance tests according to the C-PHY specification. All the tests in the C-PHY Conformance Test Suite documents can be done by using this software. In the main screen we can see three different panels. One is the configuration panel, where the AWG system configuration and DOT receiver test configuration can be done. Second is the logger panel, which provides details during the time when the tests are run. Errors occurred during the test can be also found in here. Last is the parameters panel, where global parameters can be set which will be used to generate the signal. It is divided into groups such as levels and timings. Under each group there are different properties which are given in the specification. They can be set here and are used to generate the signal. Let's get into the details of the system connection subgroup of the configuration panel. If you are used to the ValleyFrame software, this is similar to the station configuration screen of the ValleyFrame software. M8085A allows selecting the AWG which will be used. As said in the beginning, two AWGs are supported: M8190A and M8195A. By default, M8190A is selected. Below the AWG model, we need to provide the IP address of the instrument and the high slip number of the modules. M8190A has two modules. For the automatic AWG module synchronization, a connection to the oscilloscope is required, for which the IP address of the oscilloscope needs to be provided here. Only one lane configuration is possible in M8190A. The setup with the M8195A is different, as this instrument can support up to 3 lanes. When the number of lanes is changed to 3, it can be seen that more AWG modules are added to the system connection subgroup. Synchronization between the different modules is done by using a sync module whose high slip address can be provided here, and the individual addresses of the other modules can be provided here. Let's look into more details of the receiver test configuration subgroup. First, we have the choice between two options: compliance mode and expert mode. Compliance mode strictly adheres to the tests and its parameter limits as defined in the C-PHY CTS document. No property can be changed during the test in the compliance mode. In the expert mode, it is possible to change the property values. For example, if CTS says test a high level of low power signal from 1.2 volt to 700 millivolt, this is used in the compliance mode, while in the expert mode we can change this limit and test the DOT under more stress conditions. For example, from 1.5 volt to 500 millivolt. Next, we have the option to select specification. This version of M8085A supports already the 1.2 specification. Few tests, for example the jitter tolerance, test different from previous specifications. Next, we have the option to select the HS symbol rate and the LP data rate. HS is the high-speed state of the signal, and LP is the low-power mode of the signal. In the data pattern group, we can provide the sequence files which will be used during the respective HS, LP, and behavioral tests of the C-PHY CTS. Compliance sequences are selected by default. If the DOT needs to be tested with a different sequence, you can upload the sequence file here. Example sequence files can be selected in this folder. Finally, we have the Ber Configuration subgroup. Custom Ber reader can be selected to enable fully automated testing for all transmission modes. An implementation needs to be done based on the Ber reader interface. A manual for this is available in the software download page of our website. For our tutorial, we concentrate on the simplest one-lane configuration. When the system and the DOT configuration is done, we click on the Apply button. System and software are now connected, so we advance to the next screen. We see that the logger panel and the parameters panel remain the same. But there is a change in the configuration panel. It now gives us the option to select calibration or different HS tests. This can be done by clicking on the drop-down menu. There are different calibrations available, however, you need to perform them all to generate a proper signal at the DOT. To find out whether a calibration is performed already, check the circle next to the calibrations. If a calibration has a green circle, then it is performed. No mark next to the calibration means that this calibration is not performed. The connection diagram provides details to help setting up the connection correctly with the AWG system. If additional information is required to the connection diagram, you find a detailed description below. In the parameters panel, all the properties related to the calibration will be listed. As mentioned previously, those can be modified in expert mode, in which we are right now. You can see that it is possible to change the properties here. Once the instruments are properly connected, click on the Run button to do the execution. Initially, we can see the status here has not started. But upon clicking the Run button, we can see that the status changes to running. Details on the step which is being run can be seen in the logger panel. A graph will be generated if required to check the set and the measure values easily. If not, a table will be displayed having the set and the measured values. Measurement history can be seen on the left-hand side. It is easier to compare the results if the calibration is run multiple times. After looking at the calibration example, let's look at an example on how to run the test. Upon clicking on the drop-down list here, we can select HS Tests. Once we select HS Tests, we can see the corresponding connection diagram changes. After the setup is done, as per the connection diagram test, click on Run. The status of the signal generation changes as it changed during the calibration. The default BER reader provided by us is the offline BER reader, which was selected during configuration step. In order to run the test successfully, few instructions are provided in the form of pop-up windows. Follow the instructions to prepare and initialize the device. After that, click OK on the corresponding pop-ups. First, we generate the normal signal and check if the DOT receives it. If the signal is received correctly, we need to say yes on this pop-up which asks, was the test data received without errors? The next step starts, which can be seen here. Similar pop-up appears at every step and the DOT is tested with different voltage levels. So the corresponding step information can be seen in the logger panel. This test has 4 steps, and after passing all the 4 steps, we can see that the test is passed in the logger panel. Results can be seen in the result table, and measurement history can be seen as was shown during calibration run. So this is an example on how to run the test and how to run the BitifEye CTS software. Hope we were able to give you an idea about the M8085A MIPI C-PHY test solution. Thanks for watching!